I'm greeting from Indonesia. My name is Beni. I'm the member of Indonesian Scientific Society and a chemistry teacher from SMA Catholic Santo Petrus Pontianak, Indonesia. I would like to say thank you for the opportunity that has been given to me to present my research paper to you today for the 5th International Fair of Innovation and Creative Education for Youth. I want sharing with you my research paper entitled Assessing Student Chemistry Problem Posing, a Taxonomy from Semiotics Analysis. This study starts from my observation about the chemistry problem posing. We know the chemistry problem posing is a metacognitive activity. Since the taxonomy is used in the preliminary research, prefer measuring the cognitive to metacognitive aspect. Why? Because the metacognitive is too difficult to observe. Because this activity occurs on the mind of the students. To solve this problem, I propose a think-aloud activity to find the metacognitive activity, to elicit the metacognitive activity during the chemical problem posing. So, this research is conducted to design a novel taxonomy for assessing chemical problem posing by the semiotic analysis toward the think-aloud activity in the chemical problem posing activity. This is a sequential research. The first step of this research is the qualitative method. We make 2 articles in chemical equilibrium that have some characteristic about the structure, the multi-representation used in the article, humanitarian approach in chemistry education, like we present the socio-scientific issue and science reading characteristic like the interactive, iterative, and principle. We conduct this research to 20 chemistry teacher candidates, and they have to think aloud when they make the problems. After they think aloud, we transcribe the think aloud activity and we analyze this data by combining 2 data analysis. The first one is the phenomenological reduction method and the semiotic analysis. The semiotic analysis in 3 steps: the representation of the problem, semiotic affordance, and the iterative nature of the analysis. From this quantitative study, we find a novel taxonomy of chemistry problem posing. We find 4 parameters for this taxonomy. The first one is thinking level. The second one is problem structure, chemical understanding, and the last, the precision of the chemistry concept. For the thinking level, the signifier used is the question words that students use in making their own problems. We categorize into 6 levels of this thinking level, from failure to the complex problem. The second one, the parameter of the problem structure. This parameter look at the initial state, the final state, and the operator that students use to composing the problem they pose. We categorize this parameter into 6 levels too, from passing nothing to a complex problem. The third is the chemical understanding. The signifiers used in this chemical understanding is the chemistry multi-representation. We find the 5 chemistry multi-representation. The first one is phenomenological or macroscopic aspect. The second one is symbolic. The third is model or a sub-microscopic aspect. The fourth about the process in chemical reaction, and the fifth is the system. They observe the problem as a system. Okay, we categorize into 6 levels too. And the last, the parameter of the precision of chemistry concept. In this parameter, we see the chemistry concept in the initial state of the problems. We categorize into 6 levels too, from the error to the correct one. Okay. Each category, each parameter has a maximum score of 6 and the minimum score of 1. So the total score for maximum is 24 and the minimum is 4. We classify this total score into 7 categories. From the poor one, fair, lower intermediate, higher intermediate, excellent, and outstanding. Each level signifies the specific quality of problem posing skill. Now, after we find this taxonomy, we go on to the second method of this study, the quantitative study. We made an article in Chemical Equilibrium, the new articles with some characteristic. We test this article to 110 undergraduate chemistry students in second year of public university. From this participant, we find 76 data of chemistry problem, and we assess this data by the novel taxonomy we found before, and we got the actual performance of the chemical problem posing. In other side, the student should assess themselves by some indicator or parameter, and we got the perceived performance. The difference between the actual and perceived performance we call as the self-calibration. Then we confirm this data by partial least square structural equation modeling. We have 2 models. On the left side, the actual performance predict the perceived performance, and the right side, the perceived performance predict the actual. We go to the table 7. The Q square of the actual predicted perceived is positive. It means that the actual performance that teacher assess can predict the student assessment. But if we use this model, the indicator of thinking level in this actual performance should be omitted. So we modify the model, become this one, the modified model. We split the actual performance into 2 clusters. The first cluster is about the constructing the problem. They are thinking level and problem structure, and the other cluster about the content, about the chemistry, chemical understanding, and chemical concept. Now, how about the self-calibration or judgment accuracy in chemistry problem posing? When we find our student overestimate to assess their chemical problem posing, we have to give them some feedback so they can learn more and become more accurate assessing their skills. So, from the study, we find the four parameters: thinking level, problem structure as the problem cluster that arrange this taxonomy, and the chemical understanding and the precision of common concept as the content cluster in this taxonomy. And the four parameters are confined as the parameter that can be used to assess our student chemistry problem posing. I hope this research can help uh, chemistry educators around the world to assess their students' chemistry problem posing, or can be used by other science teacher. And you can modify this taxonomy based on your subject to assess our student problem posing skills. I think enough. Thank you for your attention.